you first must write out a chemical equation for the dissociation of formic acid. So for the dissociation of our acids, our weak acids, we're going to use water. So first thing you want to do, write out that equation. So it's formic acid plus water is going to make formate ion and H3O+, which is the same thing as H+. Don't forget that. When you see H3O+, that's the same thing as H+. So this is our chemical equation for the dissociation of formic acid. We start with formic acid, and we add that to water. Water acts as a base, and we'll take the hydrogen from our formic acid. Number 2 is just providing information. For number 2, we're saying that the Ka for formic acid is 2 times 10 to the minus 4, and this is a ratio. This is a ratio of our dissociated molecules, so H plus and HCOO minus, which would be our formate ion, with our formic acid. This is a ratio. And we can use that ratio to calculate H plus concentration with the given information in part 3. And you can use it in multiple situations, most likely to calculate H plus amounts after either a reaction or a dissociation to figure out the pH. So that's what we're going to do for number 3. Suppose you have a solution containing 2 molar formate ion, so that would be HCOO minus, and 1 molar of our formic acid. The question is saying, solve for H plus concentration using Ka. Our X is going to be our H plus. So we're going to put the X in the first bracket here, because that corresponds to our H plus in the bracket up here. In the second bracket, we're going to put our concentration of HCOO minus, or formate. Remember, brackets are a symbol for concentration. So it's asking for concentration, which is molarity. So the formate molarity is 2. And on the bottom, again, is our molarity of formic acid, so we will put in 1 there. I'm getting these numbers from the problem. And then we can solve for the amount. We have 2e negative 4 divided by 2. And we get 1 times 10 to the minus 4. Molar. I did that by multiplying by 1 and dividing by 2. B says, find the pH of the solution, taking the logarithm of the H plus concentration. So recall that pH is equal to the negative log of the H plus concentration. We found the H plus concentration in the above problem. That's what this is, H plus concentration. So we can take the negative log of that. The 1 is unnecessary. It's just 10 to the 4th, so our pH is equal to 4.